Right, Sergeant Chemistry class. Today we're talking about significant digits. So what's significant? Well, the certain digits and the estimated digit of a measurement are called the significant digits of a measurement. That's the book's definition, and it's a good one. So if you watch the uncertainty and measurement video, you know the certain digits are those that are basically stamped onto our measuring device or given to us by the measuring device. And the estimated digit is what we ourselves estimated that final place to be. So if you didn't watch that, you should really go back and watch it now, or else that part's not going to make very much sense. But really quickly, let's take a look at some basic scientific notation. So remember, we could write 1000 as 1000, or we can write it as 1.0 times 10 to the third. Both are the same. As far as significant digits, though, this is going to make a lot of a difference. Again, same thing, only backwards, basically. 0.00000548 is the same as 5.48 times 10 to the negative sixth. So sometimes these zeros are just going to act as placeholders. So if you see a 0 that is just a placeholder, it's not going to be significant. There are some easy rules to follow. So first off, if you know how the measurement was made, you took it yourself or your lab partner did, whatever, just include all the certain digits and the one estimated digit, and you're done. You'll have the correct number of significant digits. You can count them if you like, but really not that important. If you don't know how the measurement was made, you need to look for a decimal point. So, first, if there is a decimal point, start counting from the left with the first non-zero and continue to the end of the number. So with this example, we'd start counting. Here's our first non-zero, the 4. So 1, 2. So this number here has 2 significant digits. If there is no decimal point, start counting from the right with the first non-zero and continue to the start, or the beginning of the number. This side is the beginning. Maybe not really in math terms, but it is for now. So we'd start counting from the right. There is no decimal. So 9. Okay, that's our first non-zero. So 1 significant digit. So therefore this 900 number only has 1 significant digit. Alright, let's take a look at a couple of examples. So I'd suggest you pause it here. I'm going to move on pretty quickly. So here are the answers. Alright, so this first one, there was a decimal present, so all of these, all 6 are significant. Second one, these first 3 were just placeholders. Again, there's no decimal, so we're starting from the right. Here, again, 2 placeholder zeros. This one, we're start counting from the left. 1, 2, 3, 4. Good kind of rule of thumb. If there's ever a 0 in between 2 non-zero numbers like this one, it's always going to be significant. The last one, 1900, more than likely would probably write that as 1.900. Either way, there are 4 significant digits. So something to kind of keep in mind when you're writing things in scientific notation, to keep track of how many significant digits you should keep. Because in a scientific notation, a number like this, all of them are assumed to be significant. So there's some rules with addition and subtraction. Basically, you find the number with the largest uncertainty, do the math, and then round your answer to the place where the largest uncertainty was found. So, imaginary problem, if you had, a bunch of different distances you were adding up. So, 0.4, 0.743, 23.7, and 1,095 meters. Now, the person who took this measurement has a long ways to go, so they probably used a different tool than these others. So it was estimating this last place. So it's estimating this last place then is any of this information really that, useful? I mean, this place is going to be estimated, so we should probably round to that spot, like logically, if you think it through. And that's exactly what we do. So since our number with the largest uncertainty was this one, it was the uncertainty in the ones place, keep track of that. Then we did the math, and our final answer should be rounded to that place. So it'd actually be 1,120. We put the decimal there to make sure that all of those numbers were considered significant. With multiplication and division, there are some rules. So you start off with counting the number of significant digits in all of the numbers involved. Keep track of the one that has the least. So in our example down here, we've got this all set up for us, even highlighted the significant digits. So we've got 4 here, 3 here, and just 2 here. So okay, we do the math, do that, and round your answer so that it has as many significant digits as there were in the number you kept track of in step 1. So this was our important number for step 1 because it had the least number of significant digits. So we can only keep 2 significant digits in our answer. Therefore, we're going to round to the 10th place, and 4.8 meters would be our final answer. Here's some more examples for addition and subtraction. Just go ahead and work those out if you'd like. I'm going to skip ahead. Okay, this first one, you might be tempted to say 2,000, but in fact 2.0 times 10 to the third would be a better answer. We have to keep 2 significant digits because we're going to round to the 100th place, so we need to show that in our answer. This second one was pretty straightforward. Both of them were were estimated in the 10th place, so our answer will keep the 10th place as our final answer. This one, our final answer should be 1,000. We're only keeping 1 significant digit in our answer because that's all we have to work with that first number. They didn't show any subtraction ones here. Kind of noticed that a little bit late, but it works exactly the same. Here's some more examples with multiplication and division. Go ahead and work them out if you'd like. Skipping ahead, this first one, we have 3 significant digits in our least number, so we can keep 3 in our final answer. Again, here we have 3 and 2, so we can only keep 2 in our final answer. So we have to round to only keep 2 significant digits. This one works out quite a bit different on a calculator. This one here, 2 significant digits and 5. We can only keep 2, so our final answer ends up being 2,500, not 2,500.00. So you might be tempted to keep the decimal place there, but remember, 2 significant digits, so we need to show 2 significant digits. The last one, just rounded to 86, so hopefully this is starting to make sense. If you don't understand, or if you need some clarification, come talk to me in class. Goodbye for now.